So I turn to the pre-slaughter stage, which is a stage which involves a lot of interactions with people. So it's a very important and crucial stage for the human-animal relationship. The pre-slaughter stage actually starts with the moment that the farmer takes preparations for the animals at the end of the production round to be caught and then transported, and then in most cases transported to the slaughterhouse. So the pre-slaughter stage starts with the preparations the farmer is doing and ends with the moment they arrive at the slaughterhouse and are being unloaded at the slaughterhouse. I will certainly not cover all topics that are relevant here in this lecture, but there is a very good review and scientific opinion written on that stage by the EFSA in the EFSA report of 2022, and you can find the link here. And an also useful document here is the Guide to Good Practices for the Transport of Poultry that was published by the consortium of the Animal Transport Guides project. And you find also a link to that report at the bottom of this slide. So what does EU legislation tell us about the pre-slaughter stage? Well, it's Council regulation in the EU 2005 that currently defines the responsibilities of all the actors, so the farmer, the catching team, the transporter, the slaughterhouse, that are involved in the transport chain of live animals entering or leaving the EU. And that includes monitoring tools, inspections, and means of transport. Very recently in the EU, they have written a proposal to change this Council regulation of 2005 with a new proposal for a regulation on the protection of animals during transport. And this proposal has been adopted by the EU Commission, but it is still to be approved by the EU Council and the EU Parliament. So it is not legislation as yet. And the main objectives of that new proposal is to reduce animal welfare problems linked to long journeys and repetitive unloading and reloading linked to several resting periods, to ensure that animals have more space when they are transported, and to improve the conditions of transport of vulnerable animals, avoiding exposure of animals to extreme temperatures, and to facilitate enforcement of the EU rules on the protection of animals, including through digitalization. And also to better protect animals exported to non-EU countries. In that EFSA report that I talked about in a couple of slides ago, they stated and summarized what are the most relevant welfare consequences of road transport of domestic birds for the different stages of the pre-slaughter. So this is the preparation stage, the loading stage, the journey stage, the arrival at the slaughterhouse, and then the uncrating of the animals at the slaughterhouse. And then you can see what the main welfare consequences are per stage of pre-slaughter. And so there's handling stress that is mainly, of course, during loading and then also during uncrating. There's a risk of bone lesions in all 4 stages, and so on. So there's also the risk of prolonged hunger and thirst, especially when journey times or waiting times at lairage at the slaughterhouse are long. And the welfare consequences, its severity relates with negative emotions, negative affective states that relate to discomfort, stress, exhaustion, fear, frustration, and pain. Here are some numbers of prevalence of different welfare problems during the pre-slaughter phase from broiler chickens that were studied in Belgium. In Belgium, annually there's about 300 million chickens that are being transported to the slaughterhouse, and we see that 30% of them has scratches and wounds that incurred during the pre-slaughter phase. About 3.7 have bruises, 2% suffer from heat stress, almost 2% have wing fractures, and dead on arrival, so mortality, is 0.3%. You may think that some of these percentages are low and therefore not such a huge welfare problem, but if you look then at the number of animals that are affected, even if a percentage is low, it still affects huge numbers of animals. And these are only data for one country, a small country even, like Belgium. An important aspect of pre-slaughter, of the preparation phase, the first phase, is to check whether the animals are fit to be transported. So in our country at least, and in the EU, we have regulation on that, and animals ought to be checked whether they're fit to be transported. It says in the EU legislation that no animal shall be transported unless it is fit for the intended journey, and all animals shall be transported in conditions guaranteed not to cause them injury or unnecessary suffering. And it's with that kind of legislation, it is very difficult to set very standard criteria of which characteristics of a bird allows us to categorize them as fit or non-fit for the journey, because you have to look at it. You have to make that judgment depending on what type of journey it is. It has to be fit for the intended journey. And not all types of journeys are the same. Some are of a short duration, some are of a long duration, some are in hot conditions, some are in cold conditions. And you have to take that into account for making the decision whether animals are fit to be transported or not. The reason why unfit animals should not be transported relates, of course, to their welfare, because sick, wounded and weakened animals have higher risk for additional animal welfare problems during transport. For example, an animal that is weak will have more difficulty avoiding aggression or keeping its balance during transport. Who is responsible for checking that only animals that are fit for transport are actually loaded onto the truck? Well, that depends whether it concerns a short transport or a long transport. In the case of a short transport, which is defined by less than 8 hours, it's the farmer and the driver who is responsible for that. In the case of a long transport, it's actually the animal welfare inspector that has to be present during the loading who is responsible for that. So the EU legislation says that animals that are injured or that present physiological weaknesses or pathological processes shall not be considered for fit for transport. And then they have a list of more refined criteria to describe what they mean by that. And two of them here have been presented on this slide. An example of that, of an animal that is not fit for transport, is if they are unable to move independently without pain, or if they are unable to walk unassisted. Also, if they have a severe open wound or a prolapse, that's a reason to classify that animal as unfit for transport. What has to happen to these animals? Well, they ought to be either treated or they need to be killed at the farm as soon as possible. In both cases, it leads to financial losses and costs to the farmer, because these animals can only go to the slaughterhouse if they are found to be suitable for human consumption, and that requires an ante-mortem inspection and a declaration by a vet, and if they are transported hygienically. The EFSA report, they have also provided more specific recommendations for birds that shouldn't be transported. So the recommendations for EFSA are that birds with evident signs of illness, with emaciation, with severe lameness, with open wounds and prolapse should not be transported. Also, end-of-lay hens with a poor feather cover should not be transported in condition with a low effective temperature. Animals with broken bones and dislocations should also not be transported. And chickens with wet plumage should also not be transported during cold circumstances. For ducks and geese, that is less relevant, and so there's an exception in the law for ducks and geese. Further recommends EFSA that checks for fit of transport should take place at least maximum 12 hours before the catching takes place, and it should be checked also during the catching and the loading. Staff need to be trained to be able to detect birds that are not fit for transport, and a competent person responsible for animal welfare should be present during these catching and loading events, as well as a person who is trained to kill birds that are unfit, and that also has the right equipment in order to kill these animals. Some countries have specific guidelines for identifying animals that should or should not be loaded. And here are the guidelines from Canada, with further explanations here. And now very recently we have also drafted guidelines that can be used in Flanders, both for selecting animals that should be killed during inspections during the production round, with a difference for animals that should be killed in week 1 or during the remainder of the production round, and both with indications at the individual level, but also indications of the entire flock. And then we've got specific regulations for catching teams and for farmer about which animals not to transport. So the next phase of the pre-slaughter is the actual catching and the handling and then loading of the birds onto the truck. In the EU, there's several things are also not allowed. Things like striking or kicking the animals, apply pressure to particular sensitive part of the body. But a lot of these regulations do not seem so appropriate or so relevant for chickens, and seem to be more tailored for pigs or bovines to be transported. And one of the things that stands out is that the EU regulation actually doesn't allow lifting or dragging the animals by their legs, whereas carrying the birds inverted by carrying them by their legs, like on the picture here, is the most common catching method used for poultry in most countries in the EU. So most of our countries, the common practice is actually, strictly speaking, not in agreement with this EU law. So which catching methods are there? Well, for broilers and layers, there's 2 types of manual catching methods. As said, the most common one in most countries is carry them by their legs, by which the animals are inverted. And in that, there are 2 basic methods. You can either carry each bird by 1 leg or by 2 legs. And most codes of good practice, they recommend carrying them by 2 legs, but that process takes much longer than carrying them only by 1 leg. A method that is much less common, but is advocated by some animal welfare organizations, regards the upright carrying of the animals. So you grab them with supporting their belly and with your hands over their wings, and in this way you can carry maximum 2 birds at a time. This is the upright, sometimes called the Swedish method for catching method. For broilers, there's also the option of mechanical catching, which can happen by a harvester machine that actually harvests the animals, or systems like an automated floor belt in which they're then going to transport belts. So let's go over these 4 methods. So the first one and the most common one the inverted method. And so it can happen by one leg, most common, although not recommended, also not recommended by EFSA, prohibited in various countries. Better than by one leg is by both legs per bird, but then it takes longer, and there are some indications also that the birds are even more restless and resist more when they are taken by the two legs. Just to give you an idea about how fast that process is, we calculated on average that one catcher catches about almost 2,000 birds per hour. So it's the pace of that event is huge. What EFSA says about this catching method, they say that inversion and carrying birds by the legs will increase the severity of handling stress with 90 to 100% certainty. And it will increase the risk of injuries, such as dislocated joints, fractures in legs or wings, and bruises, with 66 to 100% certainty compared to handling birds in upright position. And this is the upright position. If you want to see a film on that, you can look at this YouTube link here. But the way it is supposed to happen is by supporting the belly and the breast with hand over the wings to avoid wing flapping. Carry one or two birds at a time, which of course will be slower than if you're allowed to carry a lot of animals per hand in the inverted position. But it has been shown that there's less of a corticosterone response, indicating less stress than when they are being carried by the inverted position. And it is also the method that is recommended by both the EU animal transport guides and by EFSA. And here are is a study that has shown that the level of corticosterone is much lower with the upright catching method as compared to the inverted catching method. So what does EFSA conclude about this? So the EFSA Animal Health and Animal Welfare Panel, they concluded with 90 to 100% certainty that handling stress is lower, and with 66 to 100% certainty that risk of injuries is lower if case of upright catching compared to inverted catching. So let's turn now to the mechanical catching methods for broilers. So the first type is using a harvesting machine, and there exist several types of machines. Like this is, this is one type of machine, but this is a totally different type of machine. The advantage of this mechanical catching is that mostly the birds manage to remain upright, so they don't get into an inverted position. And this also potentially is less stressful for both the birds and also for the catching team. And that has been confirmed in studies that have looked at, for example, the heart rate, in which they return to a normal heart rate faster in case of mechanical catching compared to inverted manual catching. Also, the corticosterone response is less, and the tonic immobility duration indicating and fear is less. Some studies, however, also report negative effects or differences. Some report a higher prevalence of broken wings or even bruises. And actually, when you look at the literature, the scientific literature, and the studies that have been conducted comparing these methodologies, they sometimes contradict one another. And that is maybe not so surprising, because a lot of the outcome depend on the type of harvesting machine and also which catching and transporting technique is used exactly, and how experienced is the team operating these machines. What EFSA concluded is that mechanical catching can potentially reduce the risk of injuries compared to manual catching and inversion if it is operated correctly. And then there's the system of the floor belts. I already talked in a previous lecture about the patio system of Vencomatic, in which the broilers live on several tiers, and at the end of the production round, the actual floor in which the broilers are living on is kind of rolled towards the transporting belt. Yeah. And so that's another way of harvesting the chickens. And there are variations on that. One possible variation is of a transporting company, the Pier system in the Netherlands. If you're interested in learning more about that, you can have a look at that YouTube link. So what does EFSA further recommends regarding the catching and the loading? They recommend that staff should be trained to avoid handling stress and the risk of injuries to the birds, that the birds should be carried upright by holding the wings against the body. The bird should never be swung, thrown or dropped. And if they are carried inverted by their legs, it should be by both legs of the animal and with maximum 3 birds per hen. And the duration that they are inverted should be kept to an absolute minimum. For example, by placing the loading containers very close to where the catching actually takes place. And we should also then take care that we avoid the animals to flap their wings a lot by placing the birds against the catcher's leg and supporting it in this way. Does any of these recommendations from EFSA have been retained in the proposed new transport legislation by the EU? Somehow, because what the proposal is for that new legislation is to still allow the catching by the legs, but to have it conditional upon some criteria. The criteria being it has to be by both legs, the breast needs to be supported by the operator's leg, with maximum 3 birds per hand and a minimal duration of being inverted. So we have just completed also our own comparative study comparing catching methods for poultry that ran between 2021 and 2024. So it has only just recently been completed, and no publications have been published about this yet. So all the results here are also kind of very new. So we studied both catching methods for end-of-lay hens and for broiler chickens. And for end-of-lay hens, we compared the 2 existing manual methods, the inverted versus the upright method. And we managed to do a comparative study in 7 flocks, in which in each of these 7 flocks we caught 300 hens with the inverted method and 3,000 hens also with the upright method. For broilers, we wanted to investigate 3 methods, the inverted and the upright, and also the mechanical harvesting method. But the mechanical harvesting method, we could only investigate in 3 flocks, and in 9 other flocks we managed also to compare inverted versus upright. So in total, in every of these participating farms, we assessed 5,000 chickens that were caught by each method. So in each farm, 5,000 chickens were followed up using the inverted method, 5,000 chickens with the upright method, and 5,000 chickens with the harvesting machine. This is a table with a lot of figures. What you see here is various aspects of the catching process that we quantified, both for layers and for broilers. We have the average results for the inverted catching method or for the upright catching method. And in case of broilers, for the inverted, the upright or the mechanical. And you see here the p-value of the statistical testing indicating when a statistically significant difference was found between the catching methods compared. So if the difference was statistically significant, the p-value is indicated in bold. And you see the direction of the difference by these A-B superscripts. So for layers, the difference we found is the fixation time. That's the total time that the animals were actually kept and handled before they were being put into the loading container. And that was significantly longer for the inverted versus the upright catching method. The frequency by which they showed wing flapping behavior was also higher with the inverted than the upright method, and the roughness by which they were handled was also higher by the inverted versus the upright method. But then regarding the labor that is needed for upright catching, that was significantly more as compared to the inverted position. We also tried to assess subjectively on a 1 to 7 scale the loudness during the catching process, the behavior of the animal during the catching process, and the efficiency by which it took place. But we've only found a trend of a difference for the loudness, in which was the inverted catching seemed to be a little bit more noisy and loud as compared to the upright. But there was only a statistical trend, so it was not quite statistically significant. What differences did we find for the brawlers? Well, firstly, quite similar differences, and the time they are being handled is longer with the inverted than the upright. The wing flapping frequency is higher with inverted, and also the roughness of the handling is worse in case of inverted. But again, more man hours are needed to catch 1,000 chickens for the upright method as compared to the inverted method, and even much less man hours are needed if the harvesting machine is being used. But again, for the other aspects, we found no statistical differences, although there was a trend for statistical difference for, again, the loudness, which was the lowest for the upright catching method, and for the efficiency of the process, which was actually highest for the mechanical harvesting method. We also did some measurements of the same animals that were caught with the different methods at the slaughterhouse, where we looked at injuries. And here you see the average percentage of animals that were injured, and here you see it broken down per type of injury. And you can see we found only for laying hens one statistically significant difference, and that was for the percentage of bruises on the wings, which was higher for the inverted compared to the upright. But for the other indicators, we found no statistical significant differences. For brawlers, we found a statistically significant difference for the percentage of animals that were injured, and that was the lowest for mechanical catching, followed by upright, and the highest for inverted, with almost 17% of the animals having at least one type of injury. And here you find the results broken down per type of injury, and we found only one almost significant difference here for the percentage of animals with bruises on their legs, which was highest for the inverted, followed by the upright, and was lowest for the mechanical catching. We also compared the costs for the different catching methods. And here you see the results for the estimated additional costs for catching layers using the upright method instead of the inverted method, expressed in euros. And so estimated is what the big difference makes between the catching methods is the more manpower that is needed to catch the same number of animals with the upright methods. So there's the big difference. And that if you calculate that to an average barn of 20,000 layers, an average flock, a flock size, then the price differential is quite substantial, in which the upright catching method for 20,000 chickens is almost 3,500 euro. That is more expensive for upright versus inverted catching. You can say this is a lot, or you could say this is peanuts. It depends a bit on how you express it and how you view it. Because if we calculated what the costs would be then per egg that these hens lay, then it would be 0.0005 euro cent per egg that would be needed as a premium price in order to compensate for upright catching compared to inverted catching. Or expressed per box of 6 eggs, that would mean that the additional price premium to pay for the upright catching would be 0.003 euro cent. We did a similar comparison for the costs for broilers, but this time with the 3 types of catching method: inverted, upright, and mechanical catching. For some, and here you see the difference between upright and inverted, between upright and mechanical catching, and inverted versus mechanical catching, all expressed in euros. You can see here the price difference for a catching event of 20,000 broiler chickens. So the upright catching method is 640 euros more expensive compared to inverted catching. If you compare upright with mechanical catching, the upright is 310 euros more expensive, and inverted versus mechanical catching is a price difference of almost 330 euros. Again, you can say this is a lot or not a lot, depending on how you express it. If you express it, for example, as the costs per kilogram of live weight, then the price differentials become quite minimal. And you can see that the upright then is kind of 1.2 euro cents more expensive compared to the inverted catching. So if you express that for the consumer in the shop buying chicken breast, 1 kilogram of chicken breast, in order to pay for the additional costs for upright versus conventional catching method, the price differential would be 1.2 euro cent. So what did we conclude in this kind of cost-benefit analysis, taking both the duration, the cost, the ergonomics, and the animal welfare differences into account when we are comparing the upright versus the inverted catching method? Well, the total catching duration for an entire flock will be 1.7 times longer, at least if the same number of catchers are being used. If we actually don't want the catching duration to be longer for an entire flock, but if you want to use the upright catching method, you then have to increase your catching team or reduce the total number of animals that will be transported as a unit to the slaughterhouse. Regarding the costs, already explained these, that the costs will be higher for upright versus inverted. We also looked at the ergonomics, and these the ergonomics of both catching methods were assessed by an experienced ergonomist, and she actually concluded that both methods were actually too physically demanding for the body and for the catchers. But when we surveyed the catchers themselves about which method they found they preferred the inverted catching method compared to the upright catching method. And so regarding the animal welfare, we already covered these. We found less bruised wings, less wing flapping, and a shorter fixation time. And we know from the literature that inversion is more stressful to them. So it's a matter of, which price are we prepared to pay for better welfare? Here are the results for the broilers. Again, comparing these 3 methodologies: upright versus inverted, upright versus mechanical, and mechanical versus inverted. Also here, upright takes longer than inverted. With the catching team, it is more expensive, but the ergonomist again said that it is too burdensome. Both methods are, but the catchers prefer the inverted to the upright methodology. And regarding animal welfare, there were fewer total animals with injuries with the upright method. There's less wing flapping and a shorter fixation time. And we know from the literature that it is less stressful if they don't need to be inverted. Apart from the method itself, I think there could also huge improvement be made by innovations in the containers and how the animals are to be loaded. And we are investigating currently kind of add-ons that can be put on the loading containers, consisting of kind of clever flapping systems that allow the birds to be pushed through, but then block the entrance so that they can no longer escape and get stuck with either their head or their wings or their legs when the container is partly left open. So we still have to evaluate how effective these add-ons are for preventing damage and injuries to the animals. So now we come to the last topic, and the last topic on human-animal relations is to do with culling and slaughtering of poultry. For this, I ask you to self-study this by reading review articles about this, and there's one specific about the culling, and that's actually an EFSA report from 2019, so fairly recent. You find the web link to that report here. It's open access, you can easily find it, but it is quite a lengthy report of about 80 pages long, and I don't expect you to read everything in the entire document. So for the exam and for the learning material, it's perfectly okay to limit yourself to reading the summary, the conclusions, and the recommendations. So certainly not all 80 pages. And then there's, for slaughter, the welfare issues at slaughter. There is a very recent review paper on that I also ask you to read. And you find again the link to the open source document here.